Sorry about that. Zoom update installing as soon as I joined. All right, I'll give Ram a few minutes to join, and then we'll just go over the doc, and you guys can decide if there's any sections you want to review offline. Okay, so 9:05, I'll get started. Hey, Andrew, so my plan is Jerry and Boon Chong, my plan is to simply go over the document for a bit, and I'll walk you through what I wrote, and I think, Andrew, you're the only one online who's going to sign it, right? I think.
Okay.
All right. So is this too big? Should I just go down to 100 again? Can you see it if it's at 100?
Yeah.
Okay, I'll leave it at 100. Okay, so this is the motherhood and apple pie section. Basically, this is the components of a link. And we're saying I'm going to specify the specification for the link controller, and how messages are transported over the both sideband. And this kind of says the focus of the spec is the link controller and messages transmitted over the both sideband. And we're not doing messages over I3C. We're just doing sideband in the spec. Then I sort of said, like, what is not in spec is no I3C. No, we're not using this control mechanism for non-BOFIs. So 1.0 will just be this, nothing else. And let's see what else. So and then there are other specs that this relates to: the link layer, the transaction layer, and the file layer. Does that make sense?
Yeah.
Okay. So then I said that these are the assumptions that this is a link as a unidirectional set of both slice pairs on directly connected chiplets. So we're not dealing with an intermediary right now. And then the partner is the interface on the far side of the link. Configuration is the assignment of slices to a link. And actually, this might be an overloaded word, so I got to mark this. Because I use configuration elsewhere too, so maybe I need a different word for this insert. Wait, I thought there was a way to insert a comment in this menu. Ah, here it is. Then one of the big opens, and maybe I should mark this as an open. We're leaving how we're kind of leaving link address assignment and slice address assignment to the implementation. And I don't know whether it's a viable. I should mark. I don't know whether that hurts.
Well, my feeling is that this isn't something that's really implementable in the sense because it depends upon things which aren't specified. Well, like the addressability, but I don't know how to
Assignment of address. So I'll show you later in the later in the spec. We kind of say you know have a binary address, but we how you get the binary address is
what it
essentially
means.
yeah. Okay. Um, then then we're sort of saying we're doing register-based messaging. Um, and we're saying we're assuming there's God and firmware to manage this whole thing, and we're sort of doing messages for we're specifying a set of messages for link bring up, but they may also support proprietary extensions in addition to the mandated set.
Mm-hmm.
So, Jerry or Boonchang, any questions? Feel free to please stop me at any point.
Okay.
So this is it. And then I said there are 5 stages to the establishment of a link. One is one is both ends of the link recognizing one another's existence. Then you're bringing up the slices, and then the link itself, and the interface on the link, and finally getting into operation. These are the 5 stages. Right now, of these stages, the interface bring up is the sort of the weakest and can be skipped if there's no credit-based transaction layers. Right, and the only requirement comes from the link layer spec, which kind of says the RX needs to send 1 credit TLP to the TX to get the link up and running. Okay. So these are the 5 sections. And one of the changes we made is originally so this is where I didn't put it in the spec, but since we're saying it's a firmware, what we've sort of said is originally I had a very detailed state machine which sort of says you go into establishment and slice bring up and everything else. And right now we've sort of left it to the firmware to figure out which stage it's in, each side is in. We're not saying you need to, this is the exit from establishment, this is the exit from slice bring up. We're assuming the firmware can recognize which stage you're in. Does that make sense? Firmware manages the firmware recognizes which stage it's in.
How does the firmware know?
Well, you're going to get some messages from the other side. So the firmware decides, oh yeah, I know the other side exists, so now I'm ready to go slice bring up. The only thing we're saying is that the RX leads the transitions, and I think we said that. I said that somewhere.
So meaning the RX have to send something back, and then that is clearly defined, right?
Yes. So the RX. So maybe then I should say the RX firmware recognizes which stage it's in.
The adjustability, right?
Sorry?
You leave it to the adjustabilities, leave it to the implementation, right? So
I'm sorry.
can we have a default reference?
You're muffled at my
Can
end.
we have the adjustabilities when you leave it to the implementation, right? So how does the implementations will handle this one?
No, so what we're saying is each slice has to have an address, some number, and the two sides have to communicate what that address is out of band. That's not controlled in the spec.
Oh, okay.
That it's not controlled in the spec, that they have to be dealt with out of band, and there has to be communicated out of band. Maybe okay, that's. And that is okay because this is a factory-based configuration. It's not a real. We don't support dynamic link bring up, right? So this is something that You're placing the parts together in the factory, and that's basically it. And so and you need to tell the other side, hey, these are my register addresses, these are my slice addresses.
So it's still the RS that have to bring out the information or the DS side.
Wait, say that again. You're really muffled at my side. I'm sorry.
So meaning there's someone have to tell us what is my address, right? So who decide that address? So it's the RS or DS?
The TX will decide its addresses, but I'm assuming that it'll hand over a configuration map, or if, since the same person owns both sides, I mean, the same designer owns both sides, you kind of know, right? It's not like all of this is happening in the blind. You're designing this part in the factory. So you know which two chiplets you're getting, you know what their address maps are, and you just sort of take care of it in the firmware. It's not like PCIe where I'm sort of bringing a card out in the wild and plugging it into a running system. Is that I'm designing, I'm taking two chiplets, putting them together. I know exactly what's what.
Okay.
Right. So we're not, there's absolutely no need for sort of a dynamic, being able to dynamically attach a chiplet to a running system. Let me see one. Yeah, so the only thing I said, while it's not mandatory, it's expected that link bringup will proceed through the stages in the order. And maybe I should put a comment in that it's led by the RX. Should I add a comment in? I thought I put it in, maybe I had an old version. Okay. And then so there are specs for tests for calibration and lane repair, and in both the Bose spec and the TLP spec, and we're saying refer to those for what the actual tests are. We're not going to specify any additional tests in this document. All this document test specifies is how tests are applied. It doesn't say which tests are to be applied. Does that make sense?
Can we give a default recommendations?
The other specs do. So the others, the bunch of wire spec and the link TLP spec has has tests for interface, for link and interface bring up.
Then we should also state it there, right? So people can refer to that.
Yep, that's what this says right here. The Bose specification mandates right here.
Oh, okay.
The TLP specification. Then I'm saying that the state of the interface is specified in registers, and we all said this already. Interface register definitions. So I'm saying there are three. There are these are the types of registers we have: Bose sideband registers, link control registers, link and interface data registers. These are specified in the TLP specification. Slice control registers. I don't think there's actually any, but we just left room for in case there's any proprietary registers available. And proprietary vendor and control implementation specific registers. That's basically it. Like I said, these are the 5 types of registers. And so in this document, we're specifying the Bose sideband registers. Actually, I feel like the more I look at it, the more I feel like they should have been a part of the sideband spec, but I guess such is life. Do you think we should just move these from the sideband, from this spec to the sideband spec, or I guess we leave it here for now? So we've got a spec for read requests, write requests, and responses to read requests. These are the kind. these are the three transactions supported on the Bose sideband. And this is straight from Ram's spec. He's not on by any chance, is he? Nope. Okay. Excuse me for 1 second. Sorry about that. All right. So this is correspondingly, I said there's 3 registers for the Bose sideband. And what else did I say? So we need a Bose sideband configuration register, straight up copied from these guys again, from dmatrix. A register to configure the Bose sideband, and then I said there's a write data register and a read data register. That's basically it. It's a fairly straight up lift from Ram's spec. So then I said there are 3 messages for link control, 3 registers for link control. Where again from Ram's spec, a partner message register, which is the only register we expect to use during normal bring up. That you use all the others only during if you're in debugging something. And that this link state register will sort of to reflect which state the link is in at each point, as far as this end of a link is concerned. And I've got an error register as well, which kind of captures these things. So one convention I've tried to follow is I've sort of always tried to make the most significant bit a public proprietary bit across the board. So you can sort of have private error codes which either mirror what's happening, or you can have your own, or you can have your complete original set of private error codes. So here, as I said, you can have your own stages. You don't have to have the stages in that way specified. But if you're going to use our stages, this is the split. Any of this make sense? Does this sound reasonable?
So are these link control registers in the address space which you read with the read and write registers?
Yes.
Yeah. Okay. So you've specified the address they go at?
Actually, I thought so. Let me check. Yeah, right here. This is how I said. Public proprietary registers, and then I think I've specified.
Okay.
Yeah, I did. Okay. Whoa, I actually did something right. Okay. Yeah. Yes, I did.
Right. You did. Okay, good.
Yeah, I'm as surprised as you are. Okay. It's been a few weeks since I wrote this. But
Yeah.
yes, I did specify that for the registers that are defined, I think I specified an address for everything that I could find. And then I left room for proprietary registers across the board. that make sense?
Yeah.
And what I've tried to do is I think I've tried to follow I order to create separate spaces for each type of register. So there's a lot of gaps I've used these type fields to sort of segregate out each type of register. So you can add more if there's more in the future, we can sort of squeeze them in. Although ideally we shouldn't have that many, given that this is just a die-to-die link. Does that make sense? Any other? So this is roughly the registers. And again, I said, if things are going well, this is really the only register you should need, the message register. And this is, I think, Jerry, to your point, this as link ID and slice, the sideband ID and slice ID, all of these are specified in the configuration, but somehow magically get to the other side, and both sides know what they are. We're just not specifying them in the spec. This is, maybe I should just call it instance ID fully. And this is what I mean, that we're not telling you how to assign these. These are going to be implementation specific, but both sides need to know what a particular address means. Does this make sense? Keep moving. Okay.
So it seems odd that we can access the read-write registers
Well, I thought we would
in the
want it for
address space
debug.
which we use the read-write registers to access, if you see what I mean.
Which are you talking about, the both sideband read-write registers?
Yeah, because the way you actually read something is by set the configuration register and then read the read data register.
Right.
Or write something to the write data register and then write something to the configuration register. So, and these are addresses, this address space is an address space that we are reading and writing.
Yes. But the thinking is that it is the way I understood it, that when you're in debug, you just want the ability to read and write everything from either side. You shouldn't use it, but you have it.
Okay. And I suppose if there's an implementation problem, then you just get dummy values there, or
Yeah.
Okay.
Well, I mean, you could see a thing where you know what the other side, that you have some fixed value at the other side that you're expecting, and you're sampling to see whether it didn't make it. It made it to the read register, to the read data register, and it didn't make it to you, right? I mean, so
yeah. Okay.
So with I guess the one thing that's beginning to occur to me is that, this debugs, if you really have all these security issues with chiplets, this debug thing can be used to cause an enormous amount of havoc. But I guess,
Yeah.
You got to choose one or the other, I guess. If you either have to trust the chip or and then the both sideband protocol is just lifted straight from dmatrix. So I just literally copied their messages, the message structure as is. So you read data, you either write data to a register and you read data from a register. Now, one thing we could do is, to your comment, should we eliminate the ability to write to these registers from the partner? So those messages should not be accepted. Things that add to write to the configuration and read write registers, or we just leave that alone for now. Right now, there are no restrictions on this. You just sort of say any address. So in normal operation, this address would only say the partner message register field, nothing else.
Okay.
So should we restrict saying under no circumstances you can write to the configuration and read write registers, or should we leave that alone?
I think you should at least allow it to be restricted, so an implementation can choose to make them read only. Write it, yeah,
Okay.
read only.
In normal operation address. Okay. And then this is the straightforward thing. You read and write, and if you read, then you're going to wait for a read response later, and error control. And if there's a message error, it signals back that there's an error of some kind. The sideband tells it. And I think I have it as only one outstanding message at a time. I don't know if I actually put that as an actual constraint, but I think so. Huh. I didn't. Okay. Is it at any instant or in any instant? All right. I'll leave it at that. Oh, I have it here. Protocol. Okay, I have it here. Then this is again says you can only do register reads, register writes, only one instruction and flight in any cycle. Read responses, and what else? And I said we need roughly these messages for these messages any sideband, but right now we're not. We don't care. We're not specifying them. And then this gets to the meat of the spec, which is the PMR instruction message fields. So this is the end of the sort of sideband section, and the rest of it is so there's some this kind of says like this is the way you can read and write. You transmit these messages, and this one says you can only have one message at any given instant. Oh right, okay. So what I did was I made that a property of the link control. I didn't make it a property of the sideband itself. Should I add that as a sideband property? So right now I just said the link control needs to be one outstanding message. Do I also sort of say, look, even on the sideband, you can only do one message at a time? Is the distinction clear?
No, what does it mean, the link control? Oh, one.
So the
Yeah.
sideband is a transport mechanism for link control messages. So I'm saying in the link control messages, you can only do one. And the link control protocol really just is what do I load the PMR with? The partner messages. So that's it. That's all it talks about. But these messages are transmitted over the both sideband. And I didn't say in the sideband protocol, you can only have one outstanding command at a time, one transaction. And in hindsight, maybe I
I think
should.
that's a reason. I think that's a reasonable limitation.
Yeah,
I mean, it maps with like, most register control buses and things like that, like
Yeah.
APB.
Okay. So that gets to the link control protocol. And all right, so this is where I got fancy. I treated these messages like instructions and I went to town on them. So the I sort of said like an instruction can be valid only in a specific stage of the link initialization process, or it could be a general instruction. I've got an instruction primary code, and then I've got a bunch of flags which tell you the sort of the scope of the instruction. And then if there's also room for an immediate value if an instruction requires that. All right. So let's just call the scope. So then again, I followed my standard convention of bit 63 is public proprietary. So people could define roughly proprietary instructions if they felt like it, but reuse everything we have here. Then does it apply to a specific state? Is this instruction valid? So Jerry, back to your old comment, if the TX receives an instruction inconsistent with the stage it's in, it'll sort of go to error or do something. But basically the RX signals what stage it's in with the nature of the with the type of instruction it sends. Then we will have a primary code which is 4 bits and a secondary code which is 8 bits. And I think I've sort of used bit 59 as an immediate value flag. If it is, then I've got something which kind of says 47 slice ID is ignored if this bit is set to 1. Then I've got a field 2b, which is a slice ID and room for a link ID and or a bit ID. I have one field which toggles between a bit ID and a link ID, depending on what you're doing. Roughly, this is the structure of an instruction. So I've got 24 bits for immediate values. Right. And then, sorry, it's been a while since I wrote it.
So, Bapi, a quick question.
You're here. Good.
So bit ID is basically when we are doing a per lane calibration, or
Exactly.
I mean, okay.
Exactly. When I'm doing something fancy that needs to apply to a single bit.
Got it. Thanks.
So I could do something that applies to a single slice in a link, or I could do something that applies to a single bit in a slice. That's roughly the intent here.
Or you could also do multiple slices, correct?
And that's the all slices flag. I've
flag.
only done one slice or all, one bit or all, one link or all. I haven't given the ability to identify groups of links or groups of slices.
Yeah, I think this is plenty configurable, I think. I don't think anybody would need anything more than this.
Okay, good. Then, so basically there's a marginal generalization of what you did already. So then what else did I, then I have a standard set of opcodes. Let me show you what they're. Sorry, I should have made this a single. Whereas, okay, I need to align my brain on this, but it'll come to me in a bit. This. Oh, right. Whether you need an ACK or not. So in each stage, I've defined a primary code and a secondary code, which kind of says like, what do you, which sets. So here's an example. This is a set slice k bit j to an immediate pattern, or set slice k PRBS to an immediate value, or set slice k pattern to ref number and immediate value. So what I've done is all of these will have the same primary code, roughly. That's kind of the split I've done, right? If you want an offset, if you have a training pattern in mind, then I created another primary code. So what I've tried to do is group similar kinds of instructions with one primary code and then do a secondary code for them. And then you get further control on whether you want to do them for an individual slice or all slices. That's roughly the nature of these instructions. Does that make sense? So if you follow these rules, you can sort of start generating a bunch of a whole bunch of actual instructions by following these rules. And there's a set of instructions that I think I recreated everything that RAM has in this. I used RAM's table and recreated every one of them, and followed these rules to set the set these So, and then I've got these ACK. So the ACK simply says whether you expect a previous request done or you get an ACK of some kind for so if you say set this pattern, I'll give you an example. So if you say set the slice K PRBS seed to immediate value, you expect the TX to kind of tell the RX, yep, I did it. And that's what the ACK says. Some things some messages you don't need an ACK. Some messages you do, like if you're already responding to something, obviously you don't need a further ACK for that. Or if the TX is saying I'm ready to train, that's from then on the TX doesn't need to know that it's going to, whatever the RX sends it is an implicit acknowledgement.
Okay.
Right. And so I'm not looking for so some of these may be weird. It requires a detailed look. So here I just said when you run a slice test, the fact that the TX is running those slice tests is ACK enough. You don't need like you don't need an ACK. But now it occurs to me that you probably do need an ACK, because if it can't, it needs to say I can't. Maybe this does need to be an ACK. Because if it can't do it, it needs to say previous.
Bapi, would it be easier to move this ACK into a separate bit so
Yeah.
that any instruction, I mean, if any instruction needs an ACK, we just set that bit when sending it across.
Oh,
So then we don't have to worry about whether we missed anything or not.
that's a clever idea. Do I have space? I probably have space for it, right?
Yeah, that's the
Okay.
other thing. I don't know if there is space.
I think you're
for
right.
one bit, then
There is space somewhere. We can find it. I think it's a much better idea. Hang on. I think it's a much better idea. Okay. All right, I'll look for that.
okay, sounds good.
Okay. Let's see. Then we've got yeah. So roughly this is how each of these instructions each of these things happened. I will okay, just changing this table alone might make me say no ACK, but we'll see. But that's basically it. I mean, so I followed these rules and made a bunch of messages for each of these. So roughly like for each message, what I did was say, let's say run 16-bit test on slice K bit I, on slice K all bits, all slices in a link, right? So I just sort of did a rinse and repeat on these things. So run the PRBS test on slice K bit J, slice K all bits, all slices link, link J, right? Or run stored. So for each one, I just went through the same created variants of the same kind over and over. Now we could just literally make this a much shorter table and say allow all of these, make it a simpler table. I wouldn't mind that either. to sort of say like every instruction you make needs to be able to applicable to individual bits, individual slices, and links or something. But right now, it's specified what the variants are, and that's it. That's a spec in it. So if there's anything I would ask you guys to look at, it's just this section here, and make sure that there's no howlers. So if I have an ACK, where would I squeeze it in? I guess I can squeeze it in here, bit 46 or 44. I just squeeze it in there, make ACK required or something. Yeah, I can squeeze it in one of these places, 34 to 32 or 46 to 44, saying ACK required. That would make an instruction much easier. Okay, that's basically it, guys.
Since you have like a few more bits, right? Maybe we can also mark one of the other bits as previous rec done. So that way, if the RX on the other side wants to send something, but at the same time, the previous request was processed, we can probably piggyback previous rec done over another command packet as well. I mean, that's an option, but yeah, I mean, it's not required.
Yeah, so I
I'm
thought
just
about
saying,
that. And I sort of said, okay, we're getting like two overlapping messages and everything else and I walked away from it.
Agreed. That would make the design. That would make this a bit more complicated. So
Yeah,
yeah, agreed.
right. And
So one other question.
Yep.
So one more question I have is, I mean, the way I look at it, I mean, I just want a confirmation from you guys. I mean, the way I look at it for the entire sideband spec as described here, I believe most of this handling would be done in software, right? I mean, if I have to look at it, I don't see anything from an RTL perspective that I have to support all these opcodes, because all of these are going to be used by the bring up software, and no design change would be needed as such. Is that the right understanding?
That was my intent.
Okay, perfect.
That was my intent, that you treat it as instruction, have some firmware decode it, and so I tried to make them 8-bit aligned and everything else just for that.
Perfect.
Yeah, so what was yeah, so we have the one instruction at a time. Yeah, so the intent was exactly to what you're saying. I don't know whether I should write that down the spec, but I didn't say that anywhere explicitly. I just said we're assuming the firmware exists, but I didn't say anywhere that the spec is written such that it can be implemented in firmware.
I mean, that's an implementation decision. I mean, you could say that the design has this in mind, but I wouldn't go any further than that. I mean, if somebody wants to implement in hardware, they should be free to.
They should be free. I mean, I've left it out. I mean, I didn't see any particular value to saying, we look at how clever we were, etc. So I just left it out.
That seems reasonable. Just keep it out.
Yeah. But I like hey, I expect an ACK flag. I think that actually follows the spirit of the spec, where we're much more explicit than implicit.
Yeah.
I think we'll squeeze that in. And so then this becomes an ACK flag. The heck? Wait, what did I do? This is really helpful. Undo control. All right.
Yeah, then you won't need the secondary code as well, right? For the because we are already having ACK as a separate flag, so you no longer need that column or the secondary code.
No, but you do, right? Because the secondary code simply says the variant, the secondary code kind of what kind, right? This is like here, the primary code is a set to immediate. And in the secondary code, you're kind of saying, set the slice k bit j to this immediate pattern, or it's a PRPS code, or the reference number. Those are the three things that the.
Oh, I see. I see. Okay. So then just the ACK column can be removed because now I think we support ACK for any opcode.
Oh, no, we still need the ACK column. We're just going to call it an ACK flag column. So you're kind of saying like, hey, this instruction should expect an ACK,
Oh,
right?
I see what you mean. Okay. Okay. Sounds good.
You should this instruction should expect an ACK from the other side. Actually, I think almost everything should default. Okay, yeah. So let me. So I think the one thing I'm kind of concerned about is reading this is a mess. So should we should it should I one way to make this table simpler is just to say, I mean that's what this table was an attempt at. Look, these are the variants that you can do. But yeah, or say we go all detail and say you must support it. For now, I've defaulted it to saying listing everything, every possible variant. Excuse me. Right, so it's like you say, let's say run 16-bit test on slice k bit j, slice k all bits, all slices, link j. So you see a sort of monotony in this, which makes it.
Yeah, I mean, yes, the table is a little difficult to read, but what I think is, I mean, it is good to have it because it gives all details. If I have to guess, I think most implementations would probably use a much smaller subset of this table. I don't think anybody is going to implement the entire table.
But leave it as is.
Yeah, I mean, yeah, that basically gives an option if that's what we want to do as a spec. But from an implementation perspective, I don't honestly see anybody implementing the entirety of this table.
Right, I thought it was actually
others can
easier
finally
to.
implement it.
It's easier to implement the table in its entirety than a subset. That was my take, right? You just sort of say when you run a test, you can these automatically allow all these variants.
Yeah, but I think that might make the firmware or the driver code a little
I see.
lengthy and complicated. So it all depends from the application to application. Like for example, the way we set up our bring up sequence, we bring up both slices together. So for us, having a requirement for individual bit or individual slice is a don't care. So we would always be doing the entire link together, and one link has
I
two
see what you mean.
slices.
Okay.
So both slices will come together. So I think that is more like an application specific. But what I mean to say is every application would be different.
Yeah.
Some applications need a per lane calibration. But if they need a per lane calibration, then my guess is they would. I mean, their application would never ever do link level calibration. They will always do a per lane calibration. So that's where I was going at.
Got it. Okay. Then yeah, I get what you're saying now. So then if you explicitly list this, some implementer can have another sheet which kind of says we support this, and this, and the rest we don't support.
Correct.
Yeah, makes sense. Okay. Well, so everybody, please get this signed in your organizations. I have these comments. Actually, that was a good review for me, at least, to sort of come back and revisit this guy. If you can, please take a look at one last look, and I'll make these changes probably in 2 weeks. Next week is kind of burned on the summit, so we won't have a meeting. So I'm going to see Brian and Ram next week in person for the first time. I'm assuming Boonchang is
Yeah,
going to make
looking forward to meet you.
Me too.
Yeah.
So no meeting next week.
Okay.
Thanks all.
Yeah,
That was
enjoy the
good.
forum.
Thank you.
Thank you.
Thank you.
Right.
Bye.
Bye.